start the course. Okay, let me go over the experiment first. This experiment is about solubility. What is solubility? Solubility is the mass of the solute that dissolves in 100 grams of water at a certain temperature. So that's the definition for solubility. So if we say solubility of sodium chloride is 34, what does that mean? It means 34 grams of sodium chloride dissolves in 100 milliliter of water or 100 grams of water. So it means if you have a beaker that contains 100 grams of water, you add 15 grams of salt, is going to dissolve, right? If you add 15 grams of salt to 100 grams of water, it would dissolve completely. If you add another it would still dissolve. Now, if you add 10 more grams to make it 25 grams, what is happening? Okay, with the 25 grams, is going to, so 25 grams still would dissolve. If you add 34 grams of sodium chloride to 100 grams of water at room temperature, it's going to dissolve. So you still get a solution. What happens if you add 40 grams? If you add 40 grams, 34 grams of it would dissolve, and the other 6 grams is going to settle down, is not going to dissolve anymore. After 34, that's it, because that's the solubility. Now, solubility is affected by temperature also. So instead of room temperature, if you have like hot water, you could dissolve more of the salt in hot water. Now, if you dissolve at a higher temperature, then you could dissolve more. Now, if you dissolve more, let's say you dissolve 40 grams at high temperature, then you cool it down to room temperature. When you cool it down, since only 34 grams is going to dissolve, then the remaining or the difference is going to precipitate. So you will see the particles coming out. That's how they make like crystals. They make like super saturated solution at a high temperature, and then they cool it down. They cool down the temperature. When you cool down the temperature, then those crystals starts coming back. If you give enough time to those crystals, they are going to stack over one another, and it gives you nice shape of crystals. But if you cool it down suddenly, yes, 6 grams of NaCl is going to remain as a solid in that mixture, because not everything is going to go into the solution. Some of it will stay out of the solution, and it will precipitate, or it will go at the bottom of the container. You would see the solid pieces in. So crystals that they are formed like over a long term. They could be more organized. They could give you like nice crystals, shape of the crystals, and then larger crystals. But if you cool it down suddenly, it would come down like all at the same time, powder, small pieces of crystals. So you're not getting like rock, if you have syrup that is made of water and sugar, very high saturation, at high temperature, you cool it down suddenly, you will get grains of sugar. But if you cool it down slowly over a long period of time, then you would get like rock sugar. You've seen those rock sugar, and sometimes to add to increase the rate of the crystallization, they add seeding for crystals. You see like wood stick that they have around the inside the center of that rock sugar that they're selling, or sometimes they have a string, and then yes, they have like a string of just a string that is inside the, you could find it inside those rock sugars. That's seeds. Yes, that's seeds, and then when it seeds, is going to give the lollipops are not crystals, but rock sugar is. Those rock sugars that they look like crystals, they are clear. Those are crystals that they actually build. Lollipops, yes, yeah, like lollipops, but yes, that's true. So you can put more solid, which is called the solute, into the solvent to make saturated solution at high temperature. When you lower the temperature, the excess amount would come out. So the table that was showing, so let's look at these, let's look at the experiment, explanation for the experiment first, and we get to the point that we have to deal with the pre-lab questions as well. So we have saturated solution. So soluble, like very soluble, you have insoluble compounds that don't dissolve. It doesn't matter. Like if you have a piece of granite, you put it in the water, it's not going to dissolve. Still is an ionic compound, is made of calcium and sulfate, or calcium and carbonate, but still is not going to dissolve. So you bring that's like insoluble compounds. Then the term of saturated versus unsaturated. In the example of sodium chloride and water, so if 34 grams at room temperature is going to make the solution saturated, if you have 20 grams of salt in the water, still is unsaturated. That means you can still put more of the salt into the water, or the amount that has dissolved already is less than the solubility. So you have to know what is the solubility. Solubility, that's the maximum amount that you could put into the solution at that temperature. So temperature is going to affect the solubility. You increase the temperature, more solubility. You lower the temperature, less solubility, and is going to come out of the solution, and it will precipitate. Solubility of gas in liquid is a different story, because solubility of the so it won't always be 34. No, it's not going to be always 34. 34 is at room temperature. At a higher temperature, it could be 50, it could be 55, it could be, and then that table that is given to you, or if the chart is given to you, you can look at the table or the chart to find out at different temperature how much is going to be. So higher the temperature, higher the solubility. That's the exception for gas. Solubility of gas in liquid is actually at higher temperature is less, because if you have soda, you keep it cold, you get, when you open it, it pops and makes more like a fizzing sound, that more gas is in there. But if you leave it open and you leave it at room temperature, it gets flat. When it says it gets flat, that means the carbon dioxide is not soluble anymore. It came out already. So that's like exceptions. But for solid in liquid, 95% of the time, higher the temperature, higher the solubility is going to be. When the solution is formed, remember the two examples from calorimetry, experiment 3 that we did. When we add the ammonium nitrate, it cooled down. So that's endothermic. When you add something else that it increases the temperature, when it dissolves, that's like exothermic process. Often it could be exothermic or it could be endothermic. So if the solubility is endothermic, means if you increase the temperature, is going to increase the solubility. You can dissolve more of the solute. So solubility of solid in the solvent often is exothermic. So if you increase the heat, more solubility is going to, you will see higher solubility. The solubility of sodium nitrate. Sodium nitrate, you can dissolve a lot of sodium nitrate in water because it's highly soluble. But if the temperature is high, you can dissolve more, even more. If you cool it down, it's going to, some of it will come back and it forms crystals. As soon as you see crystals coming out, that means that is the temperature for the saturation, or that's the maximum how much is going to dissolve at that temperature. So at what temperature it gets saturated. So you can actually perform experiment to see higher temperature is going to stay, more of the sodium or potassium nitrate is going to stay in the solution. Lower the temperature, it will come out of the solution because the solution gets saturated. The pre-lab questions is gave you this chart. Okay, gave you this chart. It says at the 20 degrees Celsius, you can dissolve 65 grams. That's very, very high number to begin with. If you increase the temperature to 40, you can dissolve 8. If you increase the temperature to 100, you can dissolve 110. So if the temperature is 100 degrees Celsius and you have 100 grams of that solvent, you can actually dissolve 110 grams of KBr in that water. Now, if you dissolve 100 grams of KBr at 100 degrees, is this solution saturated or not saturated? It's going to be, if it's 100 grams in 100, yes, is not unsaturated. Yes, good. Is unsaturated because you can, maximum you can dissolve is 110 at 100 degrees Celsius. So if you dissolve only 100, it's going to be unsaturated. Now, the dissociation of KBr, is it exothermic or endothermic? How do we know it's exothermic or endothermic? If you, as you increase the temperature, if the solubility is higher, that means heat is going to dissolve more, help it dissolve more. So it's going to be endothermic process. So we have endothermic process in here. For KBr, this solubility of KBr is endothermic. Now, if the solution has 100 grams of the KBr in 100 grams of water at 100 degrees Celsius, is this solution at 100 degrees Celsius saturated? No, because this table say that maximum you could put is 110. You have less than maximum, so is unsaturated. Now, when the if you bring the solution lower to 40 degrees Celsius, how much you can dissolve? You can dissolve only 80. So if you can dissolve only 80, what happens to rest of 20 grams? That rest of the 20 grams is going to come out of the solution. So only 80 grams would stay at solution at 40 degrees, but what happens to the rest? The rest is going to settle down. So when you cool it down, solid will come out of the solution, like crystals would form. That crystals, sometimes the size is not very large, sometimes it's large, depends on condition of crystallization. Fast crystallization would give a small powder, but a small size of powder. But if it's slow and gradual cooling, it can give you actually large size of crystals. And it also depends on the nature of the compound that you are dealing, based on the shape of the crystals. So is the solution saturated at 40 degrees? Yes. If you have 100 grams, definitely it's going to be saturated at 40, because at 40 degrees can only take 80 grams, not the 100 grams. You put 100 grams, it's more than enough. It's going to be saturated, and some of it would stay in the as a solid piece. How much of KBr is going to form when you cool it down is going to be the difference. You started with 100, now only 80 grams can stay in the solution, and the rest is going to go to solid form. So 20 grams is going to come out. Okay, we are going to experiment also with potassium nitrate. We are going to experiment and see if at what temperature is going to dissolve, or at what temperature is going to come back. So when we tested because we can't keep adding and keeping the temperature like at the high temperature or low temperature, keeping constant and keep adding, and then we find out it's going to be hard to control the temperature. So if you dissolve it and then lower the temperature, as soon as you see particle coming out, you say this is the temperature that it gets saturated. So that's the highest value that you can dissolve at that temperature. So we are going to label like 4 test tubes, and then to each of the test tubes we are going to put the grams of water and grams of potassium nitrate, and add the distilled water to it. So we're going to assume like 1 gram per milliliter is going to be using, like, we can use pipette to get the, well, if the pipettes are out here. If not, I will find something else. And then we are going to increase the temperature and find out if it's going to form the, at what temperature is going to form the crystals. At temperature that is going to start forming crystals, that's the temperature for saturation. And then we can do calculation. Okay, so should we go ahead and start the experiment at this point? Gram per 100 gram. So the first test tube is going to be 40, 80, 120, and 160, and we want to know at what temperature these solutions are going to be saturated. So basically showing at what temperature this is going to be saturated if you are adding 40 gram per 100 grams of water. Are we using 40 grams? No, because we are not using 40 grams. Then how do we know it's 40 gram in the 100 gram? Because the procedure is telling us put 2 grams in 5 milliliters. So that is going to be 40 grams in 100 milliliters. When you put 4 grams in 5 grams of water, that means is 80 gram in 100 milliliters. So these values are already calculated for you. So you don't have to be worried about this calculation, but understand where it's coming from. So if 2 gram is in 5 milliliters of water, that looks like you have a 40 gram in 100 milliliter. It's just the ratio that you are keeping. So you just want to know at what temperature this is going to be saturated. Okay, any questions from the theory? Now, did I answer questions from your pre-lab? Do you have any questions from the pre-lab? Yes, it is proportionate. Yes. Did I answer your questions for pre-lab? So can we start the experiment? Yes? Okay. Again, I need you to help me with the procedure. What is that I need to do? I'm not sure if I'm going to remember everything or not. So you got to help me with the procedure. Label test tubes 1 to 4. Perfect. So going to stop this so you could see the video. Unless going to stop that. There's no unless, we have to do that. So I stopped the video. I stopped sharing the other screen. So I'm going to depend on your procedure. Label the test tubes 1 to 4. And you cannot rush to the experiment. So since that's not allowed, so we're just going to take time and label these properly and see what happens. Okay. I think it's better for me to start the hot water bath as well. But when I have the test tubes, then I also have the hot water. Okay. So, okay, good. Just want to make sure it's visible what I'm doing here. So we are going to label 1, 2, 3, and 4. And what's next? Next step, add 5 milliliters of distilled water to each test tube. Okay. 5 milliliters of So this cannot be approximate, it has to be exact because it's going to make a difference. So I'm going to use a pipette to get exactly this equipment. It's called pipette, and this is the pipette pump. So with the pipette and the pipette pump, I insert the end of the pipette into the pipette pump. I think I've used it for the density. Place the tip of the pipette inside the water and wheel down to get the liquid in until this index line. So first I'm going to get pipette more than the index line, so it would go higher. Then slowly I dispense some to make the meniscus align with the index line, and that shows 5 milliliter because it says here 5 milliliter. The size of this pipette is a volumetric pipette, is not a graduated pipette, is a volumetric pipette, and the size is 5 milliliter because we have the 5 milliliters written here, and if we fill it up to the index line, it is going to be 5 milliliters. So I'm going to add 5 milliliters of water in each test tube. Okay, I have 5 milliliters. I place the tip inside the water. It cannot touch the bottom of the beaker. It cannot be on top, because if it's on top, it's going to pull air. Adjust the meniscus and get the 5 milliliter. Next test. Okay. Next, you have formal 2 grams in test tube. Grams. You have to measure 2 grams. Measure 2 grams. Okay, 2 grams. So now you see now that that's 2 grams for test tube number 1. Kind of make a funnel with the paper, and I placed it in test tube number 1. I need 4 grams for second one. Going to add the 4 gram to test tube number 2. For test tube number 2, adding 4 grams. And the last one. Eight grams. And the procedure. I'm done with that. Fill the beaker Okay. Place the test tubes in water bath and come here. I have the water bath already prepared. I'm going to leave these test tubes inside. Too much water. Take some water before. Give me hot gloves. Get some of the water out. Okay, your next step is we're gonna use the probe to mix it. Which one do you think would dissolve first? 1, 2, or 3, or 4? 1. I'm going to work with the test tube 1 first. I'm going to place the thermometer probe inside the test tube and let it dissolve. I'm going to use this to stir and wait until it's dissolved. As soon as it's dissolved, I can take out the test tube 1 out of the hot water bath. So in here, we have solubility, and the first one was, what did you have the first one? First one was 4D. So for 4D, we want to know at what temperature to know the temperature is going to be. What are we looking for? Can you tell me what we are looking for? I know you wrote it down. Okay. So this solution, now everything has dissolved, okay? Everything has dissolved. And now I have to wait until I see the crystals, right? I have to wait and see the crystals in order to record the temperature. What do you think this temperature is going to be? Low temperature or high temperature for the crystals to form? Yes, it's going to be low. Higher than room temperature, but lower than others. Okay. Can you put in the cold water just to get it done? It's not part of the procedure, but just to make sure that it's happening. It doesn't take too long because it's really hot in here too. So it's not going to cool off fast enough. I place it in the cold water, and the temperature now is at 43, and I don't see any crystals yet. I hope I don't need iced water. But let's see what happens. What is the... It's 34 and no crystals yet.
Professor, at what temperature did it dissolve?
If you could please type your question so it goes on the record too, that would be nice. Right? What temperature dissolves? Perfect. The procedure is not asking to record the temperature that is going to dissolve. The procedure that you wrote for me is like to heat it up to 90 degrees to make sure everything dissolves at a high temperature. So the only thing that we are looking for is at what temperature you will get crystals back. Because at the temperature that is going to dissolve, because the water is very high, the temperature of the water is very high, it could dissolve at the when it still is dissolved, right? 29 and is dissolved. So it could dissolve at 29 or any temperature higher, but I don't have the lowest temperature yet. That at what temperature the 2 gram is going to dissolve in 5 milliliter, which is a solubility of 40 gram per 100 gram, and we are trying to experiment that temperature. We want to know at what temperature it's going to dissolve completely. So that's the cutoff temperature, basically. Any temperature higher than that, it would be dissolved. Any temperature lower than that, it will not be dissolved. So it was a good question, but that's the whole point of this experiment. We are trying to find out at what temperature, this is the cutoff temperature, that the solid is going to dissolve completely. So if we dissolve it, we put in the hot water and it dissolves, we are not going to record the accurate number for the solubility that that temperature dissolves. But when we heat it up and it dissolves, we try to cool it down, and the temperature that we are getting the crystals back, that is the temperature. That's what you're looking for, basically. I thought we need that for data. Yes, that's what you are looking for, the data. That would be the temperature. That's the single temperature you are going to record for the 40 gram per 100 grams, and that's the temperature that it either crystals are forming or the crystals are dissolving. That's the basically cutoff. Any temperature higher than that, even 0.1 degree higher than that temperature, the crystals have dissolved. Anything lower than that, the crystals have crystallized and not dissolved. Well, I'm not getting any crystals. I'm going to get water, maybe a little bit colder water. Temperature. Maybe it goes to below room temperature and still is in the solution. I don't see any crystals. This is the longest one, and that takes, but it's understood. The solubility of the potassium nitrate is much higher. It's very high. So even at room temperature, 40 grams could dissolve, it looks like it, but we are going to wait. And if it doesn't work, I go get ice. Let me ask for some ice in my palm. Oh. You see, the temperature is 24 and no crystals yet. So I just asked for some ice. As soon as we get ice, we can place in ice. Maybe at lower temperature, the crystal is going to form. I don't see any crystals yet. Sometimes when the temperature is low and it doesn't form crystals, you can see the crystals, but I don't know, is the seeding effect or is going to be, seeding is going to affect or is the temperature? The temperature has to be lower. Okay, it formed. Look at this. Can you see it's cloudy and we have to record that temperature? 24.6. Do you see the crystals forming? You see, like, it's like not snowflakes, but they are coming down. Do you see that? Okay. So crystals are forming and it's 24 point, what temperature did I say? 24.6? Okay. No need. Thank you. It worked. Yes. They have to go like just a slightly lower. Okay. You record that temperature? So that's the temperature that you record for test tube number number 1. Test tube number 2, first we have to make sure that it dissolves. Please record the number because I didn't record it with the computer. Record the number. You see, the temperature was high and it was high enough for it to dissolve, but since it was sitting and I wasn't stirring, it didn't dissolve. So I cannot say this temperature is the temperature that is dissolving because I took it out. It was hot before inside the hot water, so I cannot record that temperature. But what I could record, as soon as I see crystals coming out of the solution, I could record that as the temperature that it dissolved or temperature that crystals are forming. So now the temperature has to go lower for the crystals to form. So now we know at room temperature, potassium nitrate has the solubility of 40 gram per 100 gram. Okay, temperature is 61 and still no crystals. '56. 44.5. 44.5. 44. Yeah. 44. Sorry. 45.4. Sorry. 45.4. I wrote it down. So, but you see the crystals are forming. And I add water to my laptop. Okay. You can record a, you can do a screenshot of this. You can take a screenshot. So when the crystals are forming, and I can move to the next test tube. Test tube number 3. You see, the temperature is high, but the solid is there because we haven't mixed it well. So we have to mix it well to make sure that it dissolves. Okay. The salt has dissolved entirely in the in water. Third test tubes, and with the third test tube, the temperature that crystals are going to form, or the temperature that it dissolves, it should be higher than the 45, right? Because you have more sample in here. So it should be higher than the 45, but we don't know what temperature it is yet until we know that at 75, it didn't dissolve. It didn't crystallize. It's in the solution. So we are looking for the temperature that crystals are forming to record. Right now it's 72, 72.6, and no crystals yet. If it was like a straight line, we could have said exactly what temperature, but by the two that we have, trying to extrapolate, but we don't know if it's a straight line or is a curve. So we have to wait for the experimental value until we see the crystals. Temperature is 65. 65. Record temperature 65.2. 65.2. Do you see crystals coming out? Do you see it turning cloudy? Okay, you can take a screenshot as the more, or at least observe it. So 65.2. Yes, for test tube 3. Test tube 4. I don't know how I'm going to dissolve that. But probably as soon as we take it out, it would crystallize. It hasn't dissolved yet. It has to dissolve first before we can add the, we can expect the crystals to come back at lower temperature. So okay, you can take a screenshot of the solution because it's dissolved when it's inside the hot water. Is it clear? I don't know if it's visible or not. Is it clear? Yes, it takes higher temperature to dissolve it. But we're trying to find the exact temperature at what temperature is going to dissolve, or what temperature it will it come back to crystal. So it's clear while it's inside. I'm going to place the, gonna have to put the thermometer. I place the thermometer to measure the temperature. The temperature while is in the solution, gonna let it go up. Okay. While it's in the solution, now we have a 93 degree. The temperature is dropping. And as soon as I see the crystals, I will give you the temperature. I don't have any crystals yet, but you're right. This one is going to be much the highest of the all four. The temperature that you get the crystals is going to be highest of all four. Okay, 81, I'm sorry, 83.4. Look at the crystals coming out. Do you see the flakes? 83.4, very good, yes. They look just like flakes coming down. See, all cloudy. Okay. Okay. Are we, is this the major part of the experiment? Is there anything else with the experiment? We have to plot the solutes, solubility, and the temperature. and then you have the best fitted line, and from the best fitted curve or line that you have, then you could answer the questions exactly. Very good. Do you have any questions about the data sheet? So first you are going to record these numbers that you have, the 4 numbers. Then you can answer these questions. Is this exothermic or endothermic? Then you plot the graph. Then you can answer these questions. If it's saturated, unsaturated, or it's not. Okay, let me go back to see your questions. You could use Excel, definitely, yes. You could use Excel and find the best fitted line, or you could use graph paper. Excel is better, or any program. So you learn something if you haven't used it before. Then the graph you can the assignments, you can submit as many files as you want. So if you have the graph separately from the data sheet, you can submit separately. You need to have a graph, because if you don't have a graph, you can't answer those questions. So I'm glad you asked, because we do need the graph separately. So make sure you need the graph or as a separate file. Unless you have the data sheet and you are making PDF file, you can do everything, scan everything one page at a time. I know I see that still some of you are submitting pictures. If you could all please use a PDF file, it's going to be much easier. And if your papers are not sideway, I appreciate, because for the sideway, it's very hard for me to read, and they come up very tiny. So make sure to practice with the PDF file. And thank you for those who had the pictures and then you changed to PDF. Nice. That's okay. Gases are exothermic, exactly. Yes. Solids are endothermic. Yes. Very good question. You can answer, but if you don't do the graph, you can't answer the questions, because there is no point for the 70 degree or 70 gram. We didn't use the 70 gram. We used the 60 gram and 80 gram. The only way you can answer a question about 70 gram per 100 gram is if you have the graph and you find that on the curve. You do need the graph, yes. For pre-lab, you didn't have to submit it. But for the data sheet, yes, you do need the graph. Pictures, yes. Yes. Pictures as a separate file. You could you submit at least like 2 of them. How to do graph using this, using the experiment, you mean? No, because what you have here, it's with using the computer, and solubility is going to be on the y-axis and the temperature is going to be on x-axis. Really? Okay. I'm sorry, I forgot about it. I don't know if I actually meant not to take it, but it's okay. If I said it, I stay with what I said. Is that right? Okay. Any other questions? What happened to them? Okay. Any other questions? Okay, which mountain are you traveling that you're lost? Not mountain, I guess the where are you? What do you mean I'm lost? Oh, just about the pictures. If I said don't take it, don't take it. But if you've taken, submitted, especially if you didn't respond to any question during the discussions, you submit that you is a proof you were here and you were paying attention. So if you have it, submit it. But if I said it last time, don't take pictures, you don't have to. It's not going to, from now on, I'm not going to take points off because I said it. I guess if I need the pictures next time to be submitted, I will tell you beginning of the class again. Okay. Higher the number, the lower the temperature. Yes. Higher the number. What do you mean the number? Higher the number. It's the higher the number for temperature is going to be a higher solubility. So solubility is higher as the temperature increases. Solubility is higher at higher temperature. For endothermic processes, yes, for solid in liquid. More solid you add, more higher temperature you need to dissolve it. Very good. For endothermic, yes. So if it's exothermic, it's going to be opposite. But at least with the experiment you did today is endothermic. How do we know it's endothermic? Because heat is going to favor the reaction. The higher temperature is going to give you higher solubility, or it gave you higher solubility for potassium nitrate. Yes, you see like a, yes. Yeah, because it's recorded, I cannot keep complaining. What can I say? They turn off the AC in the afternoon. Okay. Any questions about the worksheet, about the data sheet? No questions? Let me turn off the recorder, stop the recording, and then